Hello learners, and welcome to a video tutorial over your Atwoods lab practical. Now, I saw a lot of frustration today with this lab activity, so this is going to kind of give you a little nudge in the right direction. So what the goal of this lab is to get you to see a connection between Newton's second law, F equals ma, and the kinematics equations that we were using. So we had V final equals V initial plus AT, delta X equals V naught XT plus 1/2 AXT squared, and then V final squared equals V initial squared plus 2AX delta X. Okay. Now, in the lab today, really the only measuring equipment that you had was a set of known masses and a scale, and then a timer and a meter stick. Now, if I'd given you a photo gate, finding velocity would have been a pretty straightforward process, but I didn't. I gave you a timer and a meter stick. And what a lot of you did was you measured how far the block slid, delta X, and you measured the time for that slide. And you said, well, velocity is distance over time. Yes, if you have no acceleration, then delta X is Vxt. But we clearly have an acceleration because you hung masses and you let this mass go and it slid, which means it wasn't moving and then it was moving. There was a change in speed, which means there was an acceleration. There was a net force. So you can't do just delta X is Vxt. You've got to use this whole kinematic. Now, since you released it from rest, you know that your initial velocity is 0. And so you can easily solve for the acceleration in the x direction. Well, what is the x direction? Well, if I do a free body diagram for this block, I'm going to have normal force coming off perpendicular to my surface. Then I'm going to have my weight vector. And if I call this block 1 and this block 2, I've got my weight vector coming straight down, Fg1. And then I've got some frictional force because it's sliding up the ramp, so I've got some frictional force coming back down the ramp like this, Fk. Now, I've also got tension, and then tension, and then this block's weight vector, Fg2. Now, this AX, what we do, if you remember, is we make our normal force our y-axis. And we make the ramp itself the x-axis. Which means friction is on our x-axis, and this block is accelerating straight up the ramp, which means it only has an x acceleration. Now, what's causing that acceleration? Well, that's some net force. So a lot of you were able to get that acceleration, and then it was, well, I don't know how to get Fk. Well, it's right there, okay? So what we have to do is we have to redraw this Atwoods, which is what I'm going to show you how to do. Redraw the Atwoods to help you see, well, where is Fk? How could I figure that out? Okay? Because you have Ax. This is the bridge between kinematics and Newton's second law. It's acceleration. So how do I redraw this Atwoods? Well, what I'm going to do is I'm going to swing this mass up just like that so that it runs right along, the string itself runs right along this x-axis. So here we go. I've still got my table, ramp, but now I'm not going to have a pulley. There's block 1, and then I'm just going to connect it right to block 2. So I swung it up. It was originally, here was my pulley, and here was my string, and there's my block, there's block 2. So I swung it up just like that. So I've still got my weight vectors. This one's coming straight down, Fg1. But now this one is coming out just like that, right along my x-axis. Now, I've still got my tension forces between the two, Ft, Ft, and I've still got this block's normal force coming off perpendicular to the surface. And now I've got frictional force coming back down the ramp. Now, here is my y-axis, and there is my x-axis. So imagine gravity, this thing's weight, is just pulling it up the ramp. It's accelerating up. Now they're both moving together, which means they both share the same acceleration. So if you think about it, it only has an x acceleration. So you are going to sum your forces in the acceleration, and that's going to equal your mass times your acceleration. Now what should you use for mass? They both move together, which means you are going to use total mass. So do what this equation tells you to do. It says sum your forces in the x direction. Well, look and see what forces you have in the x direction. Your goal is again to find mu k. Good luck.